Good evening, ladies and gentlemen. My name is Gábor and I would like to talk about structural vector autoregressions today in this video. Since yesterday we were able to publish our recent article on this field in the Financial and Economic Review online, published by the Hungarian National Bank. And since we were able to elaborate this method a lot, so I would like to provide my information about how can we fit this kind of model nicely in Eviews on quarterly macroeconomic data. So to test all this method, I would like to show you a simple Taylor-like rule calculated from European Central Bank data between 2007 and 2020. It will be long-term yields, inflation gap, output gap, and euro exchange rate. And of course we will use two dummies to represent the recessions and economic slowdowns in the Eurozone, which was collected from the European Commission's website, the business cycle clock, which represents that when the Eurozone is in recession or in slowdown. So, first of all, when we have to talk about structural vector autoregressions, we know that actually VAR, the biggest benefit of VAR is that it's able to represent endogeneity. So it's included that there are many feedback loops between variables. Sometimes we don't know that what is cause and causability. It's able to solve this. But we know that actually we have to be really careful with the error term, so it should not be autocorrelated and it should have normal distribution. Normal distribution is really important because if we want to use this model for forecasting, then it will be required. And also this error term will be highly analyzed because we can access some sort of further information on this field. So how the different shocks are transmitted through this model, it can be captured through the error term. So let's see. So first of all, we can describe the short-term restriction, that's the Cholesky, and also the long-term Blanchard Quah restrictions, which are deriving obviously, so short-term shocks will appear on short run, long-term shocks appearing much more on general levels in this model. And after that we can say that okay, if we are describing this model from here with a bit different structure, so now we have this B in it, then actually we can construct another matrix which will include as another modified error term, because we can see that now this is not epsilon anymore, this is U. And after that we can have this structure to describe this structural coefficients, and after that we think that certain coefficients are 0 and this error term immediately affects the other variables concurrently. But so this one here. So this is the most important variable in hierarchical point of view, so it affects all. But the next variable affects only the second and the third variable, while the third variable affects only itself. So why it's important is that because when we are defining the orders of variables to include into the model, actually it will be also hierarchical. Sometimes people are forgetting this in the case of vector autoregressions, that you have to find a hierarchy which variable affects all the others and which variable is not that significant, so it affects only itself mostly. The long-term restriction by Blanchard Quah follows the same thing, just in this case it's much more sophisticated, but still the F matrix is behaving in a similar way. So still we have this hierarchy, which means that if we have this data set, then actually we have to think about that, okay, but which variable affects the most? So if it's a Taylor rule, we can say that, okay, ECB follows a price stability objective, so deviation from targeted inflation will be maybe the most important for them. But also, without endangering the primary objective, the ECB can support also the economic growth or output. So we can say that, okay, output gap will be also significant for them. And after that we know that, okay, this will determine the interest rate policy, but since 2008 short-term interest rates or 2-week policy rates are nearly zero, or yeah, so they are highly constant, so that's why we are using 10-year yield, because at least it reacts on all the quantitative easing and other monetary policy decisions. Obviously there are better variables like shadow rate or balance sheet data, but for this demonstration we can say that, okay, 10-year bond is good enough. And of course we know that exchange rates will react on mostly, partially, on interest rate differentials as well, so interest rate policy will have an impact on the currency, so they have the lowest importance here. And also we need the exogenous variables. Okay, they are not in the hierarchy obviously, but still they will be there included as well. So we have all this data, we define the ordering, so after that we loaded this thing in to Eviews by clicking on import from file and then loading in the Excel. Okay, then in quick menu we are defining the VAR model. Because it's quarterly data, then we are using 4 quarters of years, and after that we are just copying in. We have to always check that the headers are the same, but I checked it already. Yeah, the exogenous variables, estimation summary is good. We don't want to imply any restrictions here because we'll do it after fitting the model. Okay, we have something, but we know that before being happy about this something, in the case of VAR models, the second issue is to check the residuals. Normality test. Oh, we can see that it's nice, because it's above 0.05 and 0.010, so it's normal distributed. Let's see autocorrelation. We can see that okay, here it's goodish, here it's not, so there is still autocorrelation. So let's see leg structure, leg length criteria. 8. And setting to 8, it says that okay, it fits well. So let's change the model to 1 to 8, and then we are running again the tests of normality, and now it's highly disgusting from normality point of view. At least it's not that autocorrelated, but still we can say that okay, maybe the problem is that we included the slow part. Go back. So what is happening when we are excluding the? So part is still normally distributed. We can see that its data is not that high, but also if you are checking for autocorrelation, we can see that mostly exclude the exclusion of slow growth periods. So this and this and these periods were actually improving the model. So that's why we are keeping this setup. Obviously we will save this. Actually, you could think about that, yeah, but what is happening if we are using Dornick-Hansen? Okay, it's not that great. But mostly Lippai-Makra tests are used, so so we can say that, okay, it's good enough, because today we are here to test the structural part of this model. But before doing so, let's see the short-term responses. So, response of the, since it's a Taylor-like rule, so let's see the yield. It will be a simple Cholesky. Yeah. So it's short term. And we can see that we have only significant result for the 10-year inflation gap. And only for the first quarter. So we can see that, okay, if we are deviating above the inflation gap, then 10-year yields will increase as well. Surprise! It's, yeah, economics is working, but after that we can see that after that it's not significant anymore, because the medium line, so the median line and the standard errors are don't have the same value anymore. So this one is negative, this one is positive, this one is still positive, and all of them should be positive or all of them should be negative to have a significant result. So that's why we can say that, okay, with itself it obviously have a nice relation for 1 quarter of year, but that's all what we had here. So copy it. Okay, we have something like this. And also variance decomposition. Decomposition of this variable. Combined graph. We can see that, oh, it affects itself nicely, solely, and we can see that, yeah, second most important will be inflation gap. So that was the short-term Cholesky. Yeah, without typos. And then let's see the structural. So again here in procedure, estimate structural factorization, recursive long-term impulse response function. Actually it's highly automatic, so we can see that, yeah, it's, so it again it zeroes out that inflation target will have, or deviation from targeted inflation will have an impact on all the other variables, while output gap will not have an impact on inflation target deviation, but for all the rest of the variables. And after that we can see that long-term yields, so 10-year yields, will have only an impact on itself and the exchange rate, while exchange rate have only an impact on itself. So this is the logic here. We can see that, oh, okay, it's mostly significant, but, and also if we are interested in the structure of the F matrix, mostly we don't have to deal with this, so it's, yeah, happy that they are there. But in the case of impulse response, then we can see we have to structural decomposition must be used. We will see that, oh, now we have only impulses, and we need multiple graphs. Yep. Oh. Okay, at least okay, at least this works this way. So we can see that, yeah, results are highly the same on long run as well. So still, inflation gap is the sole significant variable on for 1/4 of years, and the rest is not that important. Obviously, we can say that, yeah, but what is happening with variance decomposition? Structural combined 10 periods. We can see that this is highly robust. Yeah, and at this point we could say that, okay, now let's write the article and we can finish the job. But yeah, first of all, let's say that this is the long term. But in this case we could oh, sorry, what happened here? I copied the wrong one. Yeah, so we could say that, yeah, but if we have to submit it as a paper, so we should rename this, and then how can we include it to somewhere? So this way is not nice, but we can define all these variables like this as well, so we can use script. Okay, so let's say that, okay, it's from a previous script, so let's adapt everything here. Okay. We are changing the tabs to spaces to make it more elegant. And then we are changing the variables. Also, we know that we should only add this dummy variable because the other was useless. And after that we just have to add up the rest of the lines. A struct, let's see, stat4. This it will be called as myimpulse without the 2. 2, 3, 4. Decomposition. This. So first of all we have to run this because it will save the output. Also we could say that, okay, let's save this as var 0, 1, or we could say that okay, let's copy this line since we made this, hit enter, and now there will be also highly the same thing. Just we have to be careful that if we are running this, then still we have to make this structural thing. Yeah. After we can continue, so we can say that okay, now this var1, oh, square root of negative number, so it's still there. Even in the case of the aggregated one. Okay, so we changed to Monte Carlo, and its accumulated impulse response. Okay, and then we can say that we can reconstruct everything in Excel. So let's say that yeah, we have to change the decimal points to decimal commas because of Central European office, and this will be the median line for each variables. So we can say that impulse response function. Okay, these are the legs. Oh, sorry, not leg, it's period. And also, what do we have here? It's a standard error. And after that, we can start to build this on our own. So we could say that -1 standard error. And also we can add the +1 standard error. And we can just define the variables, so this minus this. Here yep, and also to have the usual two standard error data minus 2 plus 2 multiplying this thing. And after that we can build the, when I highlighted, I did not highlight it everything. Yeah. And now we can say that, okay, this will be black and this will be highly narrow, other dotted. Why is it better for us? Because in many cases actually we can say that so using one standard error is providing us 68% of confidence interval, and sometimes people are using this. So if we are going back, yeah, obviously, yeah, sorry. So if we are using any kind of, so it doesn't matter that it's short-term or long-term model, but you have to provide always the data about the structure. So for us, because it was long-term model, it was the F matrix. If it's not a long-term model, if it's a short-term model, then you have to talk about the S matrix. It doesn't matter, but you have to say that which. So what is the hierarchy among variables? So you have to provide this one to your models, and yeah. And after that, still we have to say there was somewhere. Yeah, so this Abrizzo et al. Article used this kind of one standard error models, and actually it's good because in many cases it shows us that what is the underlying structure. So let's say that Abrizzo et al. 2020. Oh, somehow the next page is missing. So we can see that, yeah, this article from the Science Direct we can download it if I'm using the university Wi-Fi, and after that it's, at least in the figures we can see clearly that they were using this procedure, and it's quite widely used method, so it's much better to extract data. Okay, for inflation gap shocks we were not able to see many things, but let's hope that the rest of the variables on long run and on aggregated level they can be more efficient, and yes, we can see it here. So this was the 10-year yields response on the output gap. Shock. And it's black and it's dotted. So now we can see that, okay, in this case output gap on long term was significant not just for 2 quarter of years, but still with this narrower confidence band. Actually we can say that is for 8 quarter of years, and it had actually a negative influence. So until output gap was increasing, then still the 10-year bond yield was under pressure. It can be counterintuitive, but if we are looking on this period when actually there was a slight economic growth, then we know at the same time actually long-term bond yields were declining, and they became sometimes even negative. So we can say that this is actually what happened. Okay, also we have similar solution for decomposition. So no, not this. We have to use this function here. And it also gives us the decomposition data. Actually, standard errors are not used here, so we don't use confidence bands. They are highly useless, so that's why. But actually, still we can extract the data which is required here to make our own graph when it's needed. Okay, I hope I was able to help you to write your articles. So if you are using this video, please don't forget to cite our nice paper where we were able to collect all this excellent knowledge about structural vector autoregressions. Bye bye.